Hello, good morning. So today we are going to see the data structures subjects topic, that is algorithms and types of algorithms. So in this lecture we'll see what is an algorithm, what are the characteristics of algorithm, and what are the basic or fundamental types of algorithms. So here we'll see initially the learning outcomes, that after attending this class what you will learn. So you will be able to differentiate between problem, solution and algorithm. You will be able to write algorithms for solving any problem. You will be able to list the characteristics of algorithms, and you will be able to explain the types of algorithms. So these are the outcomes which you will get after attending this lecture. Now, let us see what is a problem first. So whenever we identify any problem, or whenever we, maybe it is a real life problem or the problem to be solved using some technology like computer. So we initially are concerned or focus upon that problem. So that is step one. In step two, we try to understand that problem by exploring the information, by creating the ideas, and then when we get some idea to solve that problem, maybe a one idea or more than one ideas, then we decide that which idea to implement, which is the simplest one, easiest one, and then we build or implement that idea or solution. And then after implementing that solution, we evaluate the results, that whatever we have implemented, whether it is really solved our problem, if and even if it is solved, the problem is solved, whether it is like giving us the expected output or a quality output. So this is the process of problem solving. Now, why we are looking at this process? Because our algorithm is also written to solve a problem. So let us go ahead and see how algorithm is solving the problem. Now here we'll see introduction to the problem. So what is a problem? So problem is a difficulty or situation to deal with. Now what is a solution? So solution is the way to deal with that problem, the procedure using which we can solve that difficulty or we can deal with that situation. After that, algorithm. What is an algorithm? Now it's a computer related term. So this term indicates that the steps written or followed or implemented to reach the goal or to solve the problem. So these steps are normally written in natural language to solve a problem. So this is the algorithm. And now we'll see what is the data structure. So in the data structure, we can store the data, we can organize the data, and that data is used or it is processed by the instructions of the algorithm. So that is the data structure. So in primary memory, we store the data using some way of that storage, and that way of storage, way of organizing that data is called as data structures. So these ways are different for different data structures. Like we have array, we have linked list, we have trees, graphs, etc. Now, what is a problem? So we have seen problem, solution, algorithm, data structure, and now program. Now what is a program? Now program is nothing but the instructions of algorithm are converted into a programming language code. So now it's a programming instructions which may consist of simple instructions, conditional statements, looping statements, or maybe some initializations, some classes, some objects, some functions. So that is all programming instructions. And these instructions are processing data which is stored inside a data structure. So instructions are processing data, and that data is available for processing through a data structure. So data structures provides the access to the data and storage to the data, right? So this is program. Now you can see algorithm is different, data structure is different, and program is different. Now we'll see again in more detail. So what are the problems, or what are the examples of problems? So we can see we have like how to start a bike. So it's a like real life problem that somebody if buy a new bike or somebody is very new to the bikes, he may say that how to start a bike. So for that new kid or new young, we that how to start a bike is a problem. Now somebody who is very new in the kitchen, maybe there is a problem how to cook a biryani or how to cook a coffee or tea. So this is a problem. Now, how to write a research paper. This may be a problem to a new uh, researcher. Then, how to search a value from a data. How to sort the collection of values. How to set up, how to do set operations. Like, so I provide you the sets. Set A having some values, set B having some values. And if I tell you to find their union, intersection, difference. So this may be a problem for somebody. So these are various examples of problems. And if we want to solve this problem, we can write some set of instructions to get the solution. So we'll see that also. So see here solution, we'll find a solution for some problem like how to start a bike. So this is a problem. Now how we can write an algorithm for this problem? So that is a solution. The solution is having number of instructions which need to be followed sequentially. So we cannot change the sequence of instructions. Like first instruction cannot be executed last, or maybe like third instruction cannot be executed first. So the sequence is as given and that need to be followed. So if we first insert the bike's key into the ignition, then step 2, turn key to the ignition. Step 3, put the bike in neutral gear. If it is automatic, then no problem. Otherwise, you need to make it neutral. And then step 4, kick or button start the bike, right? So if you follow these steps, I think the problem of starting a bike will get solved, right? So this is a solution to the problem. Now this solution is a real life word and algorithm is a computer related word. So when you write some solution for the problem which is to be solved using computer, so that solution is called as an algorithm. For example, see here we have again one more real life example of problem and solution. So problem is a pollution. Okay, so we can deal with this pollution by using uh, bicycles, by promoting bikes instead of using cars. We can go to some renewable or some natural resources like solar energy, wind energy, etc. We can avoid plastics products to avoid the damage to our nature. So these are some problems. So we'll now focus upon the algorithm. Okay, the problem or the instructions which are written to solve the problem using computer. So this is a definition of algorithm: a set of instructions for solving a problem or accomplishing a task. So this is a definition given by this particular website. Now we have this like this how this algorithm word is like coined or it is introduced. So we have this is al ga then ra them. So algorithm. Okay, so this is how it is invented. And now see, now in an algorithm, as I said, it's a collection of rules, instructions which are written in natural language, and if we follow them, so we'll get our problem solved. But now this algorithm or instructions have some input and some output. So this input is nothing but some data. Okay, so that data is accepted, that is processed using these instructions or rules, and then an output is produced. Okay, so this is an algorithm. Now we'll have some examples of algorithm like to solve problem using computer. So suppose I have a problem for what is the factorial of a number. I want to find out the factorial of a number. So this can be our algorithm. So in algorithm, I will start with the step 1, that is start. Step 2, accept a number. Suppose it is 5. Then initialize a variable fact which will give you the final output, that is the factorial of number, which is initialized to 1. And then step number 4, compute and store. What compute and store? Fact equal to fact into number. So number is 5, fact is 1. So initially it is 5 into 1 stored inside a factorial. Then decrement number by 1. So now number was 5, it will become 4. And then if the number is greater than 0, go to step 4. That is again compute fact equal to fact into number. So the fact is 5. Now 5 into 4 is 20 and store 20 inside factorial. Then again decrement number by 1, number will become 3. And if the number is greater than 0, go to step number 4. So the factorial is 20. Now 20 into 3 will give you 60. Okay, and then again decrement number by 1, number will become 2. If the now number is greater than 0, go to step 4. And now it is 60 into 2, 120. And then if the number decrement number by 1, it will become 2 minus 1, that is 1. And now it is still greater than 0. So final computation is 120 into 1. Store this 120 into 1 into the factorial. So this again decrement by number. So it 1 minus 1, 0. So now number is equal to 0. It is not greater than 0. So you now go to step 7. And that step 7 is display factorial. Okay. And then you stop. So this is how you can find out factorial of a number. Now, similarly, we can have other examples also, like a sorting algorithm. Now, in case of sorting algorithm, you can see there is a initial list having 15, 9, 30, 10, 1. Now, you can see, you can compare 15 and 9, and we want to arrange the numbers in increasing order, ascending order. So, shift this 9 here and 15. So, swapping is there. So, we'll have 9, 15, 30, 10, and 1. Now, again compare 15 with whether 15 is greater than 9. So yes, 15 is greater than 9. After that, compare 15 with 30. Now, when you compare 15 with 30, you will find 30 is greater than 15. So that is okay. But when you compare 10 with 30 or 15, you will find these both numbers are greater. So swap or shift 30 and 15 one location ahead and then copy 10 at the place of 15. So now we'll get 9, 10, 15 and 30. So the algorithm for this sorting is compare first value with the second. Now if the first value is greater than second, then you need to swap or shift the values. Okay, and similarly go on for second value, third value, fourth value, and so on. Okay, and whenever you find the previous values are greater than the next value, you can shift or swap the values. So this is how we can write algorithm for sorting. Now these are the characteristics of algorithm. That algorithm should be well defined. It should have some output. It should have some well defined inputs. So 0 or more inputs are possible to algorithm, but at least 1 or more outputs are necessary for an algorithm. Now finiteness, so the number of instructions in the algorithm should be finite. They should be limited, fixed, and it should be feasible. See, the algorithm, the steps written in the algorithm must be implementable, feasible in the real world or using some real computing machine. Now, algorithm is language independent. So you can write algorithm in Marathi, Hindi, Tamil, Kannada, Kannada, in any language. Okay. So it is language independent. So you need to write algorithm in any programming language. Algorithm is language independent. You can write in natural language, any natural language. Now clear and unambiguous. So each step in the algorithm should be clear. It should not have double meaning or multiple meanings. So that is clarity and unambiguity. Now there are two fundamental types of algorithms, that is deterministic algorithm and non-deterministic algorithms. Now deterministic algorithms are the one which produce the same output no matter how many times you give a particular input. So you apply the same input any number of times, it will always produce the same output. And examples of such Deterministic algorithms are searching algorithms like linear search, binary search, and sorting algorithms such as merge sort, quick sort. So there are many deterministic algorithms, and second category is non-deterministic algorithms. Now, these algorithms may produce the different output for the same particular input at different instances. So if you run it first time, it may produce an output. Second time, it may produce the same output, or it may produce a different output. So that is a non-deterministic algorithm. The example is get det function, and second is a random function, like we can retrieve a number randomly from a collection of numbers, and get that function. It always retrieve a different date. It always retrieve a different date every time it is called. Okay, so these are some examples of deterministic and non-deterministic algorithms. So I hope you understood what is an algorithm, what are the characteristics of algorithm, and what are the types of algorithm. And the basic thing is we write algorithm to solve problems. So the algorithms consist of instructions which processes the data, that is the input, to generate an output. So thank you. Happy learning.